Hey guys, welcome back to the live stream tonight. So this one is my solution for overpriced lithium batteries. So it took me a while to kind of figure out how to put this together because the way that I figured out how to get a cheaper battery was difficult for me because I want quality in the vans that I build, but at the same time, I want to take into account the budget of the customer that I'm working with, because there's other stuff in the van that might be more important to them than just the battery system. But I know from experience that having a good battery system, sometimes a little oversized, is going to help them for the long run. But if you're doing a DIY build right now and you're looking for a battery system, the prices are all over the place. They can range anywhere from $500 per battery to $1,000 per battery. Yet all of the features on the battery kind of look the same. So how do you know where's the roadmap to kind of go through and compare and contrast the batteries out there? So just like I said in the last stream, I'm only going to talk about stuff that I know and have used in the van. I'm going to put some notes here on stuff that I understand as far as how ways that I figured out how to size batteries properly on my van build journey. And then I'll talk about the vendors and stuff like that I've found online. Again, no affiliation with these guys, just getting you guys some good content to help you with your van build process. But let's go ahead and get into our slide for the night. So we're going to come back to this thing a lot, and we're going to make sure that I go through each one of these things, and you guys can kind of use this as a cheat sheet going forward when you are putting together your van. Use it as kind of like your budget sheet and notes type of thing. All right. So why is it so hard to choose a lithium battery? Well, for me, it had to do with price to performance. And I'm going to keep bringing up Thomas's van because we just did so many technical things on it that we got to put, the coolest lights, an awesome awning, an awesome fridge, and a power system for him to recharge, like a lot of components. So because we had a lot of technical items on the van, that's just a fancy word for saying expensive items. We wanted to allocate that budget out. We wanted the Baja design lights, and we wanted all of them. We didn't just want like the ones on the front. We the light bar, stuff like that. So we needed to be really careful with the budget. Really, really getting down to the dollars and cents on what we could put into the build and then also, what didn't make the cut. So what I did is it was kind of my thought process. So I'm going to start this off with what I think the problem is with choosing lithium batteries for camper van builds. I think what's the hardest thing is what I said in the beginning. All the features look the same on paper, but the prices are all over the place. So we'll get to this section over here. But let's start out with a couple reasons that it might be hard to choose a lithium battery. So the first thing is, I would ask yourself, are you price sensitive? Or are you brand sensitive? Because that's the first question I would ask. Because if you are brand sensitive, like Windows versus the Mac, that you're a Mac guy or girl, and you're going to pick up that laptop because it's just Apple. But there's another school of thought to where, maybe you're a little bit more frugal, or you're on a budget and you want to get something that is in your budget. So that would be the first place I start. Oops, let me come back here. Here we go. If it's brand, then it's pretty easy. If you're into Battleborn batteries, go for it. If you know that's what you want and you have the budget to do it, that's pretty easy. You just go on their website and then you go and find out the capacity of battery that you want. Give me 1 second. I'm going to turn this AC off. There we go. All right. So price or brand. Brand's easy. So for example, if you do go by the brand, then you got the Apple tax. So it's gonna cost you. If we look at these prices over here, I want to get this later, but this is right where I'm talking at the moment. Like Victron Energy. Now this is for a 100 amp hour system, not a system, battery. We're just looking at a single 100 amp hour battery purchase. So it looks like Victron Energy. It's $1,000 for one of their batteries with a built-in BMS. Very expensive. Or we've got $570 for the SOK. So then $874 for the Battleborn. So if you're kind of brand loyal, it's pretty easy which one you're going to go with, Battleborn or Victron. SOK is kind of this new kid on the block, and I was very interested in it. So we're going to talk about why this is the one I chose. So I'm kind of going to the end, and I'll rewind here. So the first thing, do you buy because of price or brand? That would be the easiest question. Once you answer that question, you're on your way. These other questions don't really matter as much because all those features that you're looking for are probably already baked into the name brand battery. The next one is, are you buying it because of capacity? So some of the name brands like Battleborn, for example, they have the Game Changer battery, and instead of buying one battery that it's 100 amp hours and you're getting 4 or 6 of them, with the Game Changer batteries, they're like, don't quote me, but it's like 275 amp hours for one battery. So you could get just 3 of those instead of having to purchase, 6 or 8 of like a normal brand in a 100 amp hour format. The next thing has to do with the built-in battery protection system, or the battery management system, which is the BMS. And if I'm losing you guys here just a little bit, ask me questions in the chat. Love to hear your questions. So BMS, if you don't know what a BMS is, we're just going to go, oh goodness, come on, Wikipedia. BMS, it's essentially a system that protects the battery from operating outside of its safe area. So you can kind of think of it like, it's kind of like, it's like a mini computer inside, and it's always looking to see the stated charge, what individual pack or cell voltage is. It helps it with, overcharging. One thing that's incredibly important is to make sure that it does not charge at a low temperature or a temperature that's too low. It's essentially freezing, but some of these new lithium batteries can go below freezing. So like negative, instead of 0, they can go down to negative 20 safely. But you want to have that disconnect protection. So these are just some that were off the top of my head. Low temp disconnect, which is really important. And if you're not familiar with, again, these batteries at all, put it in the the chat box, I'll answer this, but low temperature disconnect, a lithium battery, so specifically lithium iron phosphate. So not the same that's in your cell phone, like a different chemistry. So lithium iron phosphate can discharge at a very low temperature, but if it gets down too low, freezing, -20, that type of range, if you try to charge it, you'll permanently bold. So say that heater can't keep up because you're in the Yukon or something like that. What'll happen is the batteries will disconnect, essentially turn off. This is another way to think about it. And the solar can't provide a charge to them, and it won't damage it, so that they're safe. And then typically what happens is when the battery gets back up to temperature, the BMS will reset and allow it to continue charging. So it's almost like nothing happened. Some other things are high temperature charging. So cars like Teslas and stuff like that, the battery bank actually has like a cooling circuit, almost like a liquid AIO on a computer, if any of you guys are into building computers. So it'll have like a grid, and it'll pump coolant through the battery system to absorb the heat when the batteries are being charged at a high current. So if your battery's in your van, so say that you have your van, it's outside and you're going hiking and it's 95 degrees, or in Arizona it's like 100 and something like that. It's probably like 120, 30 in your van. Sometimes depending on the specifications of the battery, it'll be too hot to charge. So it needs to disconnect in that situation. The other one is overcurrent. So imagine you have a charging system for your battery. It could be solar charge controller. It could be a DC to DC from your engine battery. And say one of those systems runs away. And what I mean by that is whatever circuitry limited them from giving you a certain voltage, charge voltage, just say it started going to like 15, 16, 17 volts, like whatever was outside the spec of the battery, that could damage it. So overcurrent is also built into the BMS. Then you have simple things like short circuit protection, circuit breakers, stuff like that built in. And then another one is a sense cable for the battery to auto balance the cells. And again, if this is all going over your head, we could definitely explain this when we get into more like electrical videos about van circuits, because we can talk about that in depth. But essentially, there's cables within the packs inside the battery, the lithium iron phosphate battery, and there's sense cables. And what those cables do is certain batteries have groups of cells that are combined together. And if one of those packs is charging at a faster rate or slower rate, the BMS can modulate the charge rate to those different packs so that you get an even charge. Now, rule of thumb is you want to fully charge all your batteries in your battery bank individually. So say you have 400 amp hour batteries. You want to take them all out, put them on the charger individually, get them topped up all the way, and make sure that each one of them reads out the same voltage before you wire them together in series to run your system. And then the next thing would be talking about series. Can these 12 volt batteries be wired into a 24 or 48 volt orientation? All right. Okay. Is our stream back? My OBS said it was disconnected the stream for a second and reconnected. So, yeah, let me know if you guys can still hear me at the current moment. All right. Sounds like you guys can hear me. So we might have, okay, let's go back here. So what I'm talking about, let's see, what time did you guys join here? What time was this? Yes, Daniel, I will talk about the batteries that I'm installing. Now this is cool. If you guys are late, that's all good. I'll do a really quick summary about what I'm talking about. So it seems like it's very hard to choose a lithium battery because the prices are all over the place and the specs and features, they look the same. That was my experience. So what I did is I put a little cheat sheet here for you guys so that you can go through and you can have a process to look at, not to be corny, but like be a smart shopper. I don't know anything better to say. Know what you're kind of talking about before you spend a lot of money. Because these batteries, they're really, really expensive. For example, this SOK, like I was saying earlier, it's $570. Battleborn is $874. And then Victron Energy is like $1,000. But these batteries are all 100 amp hour. They all have BMSs built into them. They roughly have the same cycles. And what's kind of funny is the warranties are very close. Victron actually makes you, they say 10 years, but it's because they give you the option to purchase an additional 5 years after you purchase the battery. So I did some research for you guys. When you look at the fine print, it's pretty funny. So I'll tell you what, I went with the SOK, and so we'll talk about why I went with the SOK as we get to the end of this. So I'll quickly go over this little problem section. If you're buying price or brand, it's pretty easy if that's your only two things. So if you have the money to buy the brand you want and you're an Apple guy, or Windows person, and you're going to do that anyway, don't really worry about the budget. But if you are on a budget and don't think about a budget being negative, because say that you could do a better job on the battery budget and that gets you a better fridge, for example. You're just kind of moving the money around in your budget. You're not really losing anything. If anything, you're gaining something by being more on budget and kind of get your best bang for the buck. Then moving through here, we talked about really quickly about the BMS. That's the battery management system. That is what is like, it's like a little mini computer that is looking at all the systems of the battery, the cell voltages, if they're high, low, if you're charging at a too high of a temperature, if it's too cold outside to protect it. So we kind of talked about that, and then we're getting right back up to real time here. We talked about, can it be wired in 24 or 48 volt series, and that has to do with your power system. Those higher voltages allow for lower current, which means your wire size can be less, and you don't have to get such a thick, chunky wire that's more expensive. Most people do this if they want to run a 24 or 48 volt AC unit, like a real high efficiency one. And I would say that people in this camp are not really budget. They can have a bigger budget. So they go for the kind of higher efficiency option. But that doesn't mean 12 volt systems are bad at all. I stick with a 12 volt system because if you can imagine, if I build your van and something breaks, regardless if it's a manufacturer defect or what. If you can't go on Amazon and quickly get that part, or go to a manufacturer and it's on the shelf, it's probably going to mess up your trip. So if you decide to go with a 24 or 48 volt system, those items are not readily available on the shelf. There's not too many of them on Amazon. So if you're in a pinch, it's hard to quickly get a replacement. So 12 volt stuff is much more, it's just readily available. It's cheaper, it's more volume when they, people that produce it. And then the last thing on my little kind of getting you prepped is the warranty. So kind of mapping out the warranty of different manufacturers. And they're pretty much all competing in the same market. So they should be very close to one another. It's funny to me that Victron is less than SOK, which is interesting because, SOK, overseas brand. So, all right, let me tell you how to fix this problem. How do you make it easier to choose a lithium battery? So, let's make sure there's not a question here that I might can answer quick. What are you talking about besides? So Daniel, I will get, after I talk about the lithium batteries, I'll go into a little Q&A, and we'll talk about like lead acid old school or like AGM and stuff like that. Because all of this information will apply to it. There's just a little twist about lead acid AGM batteries that I'll tell you about. It's really simple, but let's save that for the end. So I got your question right here. So how do you fix the problem? Well, the first thing is, it's a little canny phrase I just made up, but it's know the nomenclature. The nomenclature. And nomenclature, if you guys are gonna make me tell you what this is, it's pretty much the words that are used in a particular field. So when I was, where we go? So when I was an engineer, wait, did I even go to that slide? There you go. Know the nomenclature. So when I was an engineer and I was green, and even though, they teach all this stuff in college, there's still all these different specific words and stuff that explain like gearboxes and hydraulic systems, and you just kind of got to know what you're talking about. You got to learn those words so that when I went to go and talk to like a vendor or a machine shop, I can communicate and I don't sound like I'm, straight out of college, right? So you learn those words of the industry. So the words that I'm going to teach you guys, and you may know this, you may not. This video is for everyone. But you need to know what battery voltage you're working with. So 12 volts to stay simple. 100 amp hours. So 100 amp hours is, I'm trying to give you guys a real simple explanation. So don't get technical with it. Don't turn it into watt hours and all this stuff like that. Just use it as that's how all the companies are describing the same amount of energy stored in the battery. It's a 100 amp hour battery. Okay, stay simple. Don't go down the wormhole. Next, the BMS. So the BMS, battery management system, they should all by default have one built in. Now, Victron Energy does have a system where when you get to the bigger systems like the 200 amp hour systems or even the 100 amp hour with multiple batteries, they have a central BMS. So there's a central BMS, and the all the batteries plug into the central BMS to communicate. And that's just kind of a Victron Energy thing. Let's see here. the 3 Dakotas. Yeah, Dakotas. I don't know much about them other than they're a lithium battery just like everyone else, but I don't know the specifics if they have, built-in BMS. And to me, the number one safety item on a battery is a low temperature disconnect. If you guys know, let's see here. If we go this guy, Will Prowse. I think everybody that's watching, if you don't know who Will Prowse is, you should go check him out. He's kind of the guru of, 12-volt systems, and explaining in detail, kind of the nitty-gritty behind everything. So I'm going to kind of go over here to his YouTube channel. So this is his YouTube channel, Will Prowse, Off-Grid Solar Power channel. And he's got amazing videos. So videos on battery reviews. And so his channel is how I found out about SOK batteries, because I've never heard of them before. But this will actually show you, once you watch this battery, man, it's late, right? Once you watch this channel just a little bit on the SOK and how he compares it to like the Battleborns, he takes a multi-tool and cuts through all these batteries, rips them open, and tests them. So you really get just the best view of how a battery is designed and made, and there's really no way for the manufacturer to hide behind fancy branding, sticker labels, stuff like that. He cuts the batteries open. He tells you if that low temperature disconnect wire is there or it's not there. So the marketing material could tell you that low temperature disconnect sensor is on the battery, but he's going to cut it open and take the camera and show you that it's there or not there. So the next part would be size, like weight and dimensions. And okay, let's go here. So don't mess this up. It's an expensive mistake. And you don't want to mess up by buying the wrong battery. And if any of you guys have already bought a battery and you're just using this to kind of learn about the battery you bought, you're probably fine with the battery you bought. So I'm not saying that's you messed up, but this is kind of the order of importance to me. It's just my opinion. So you need to know your capacity. So you need to know the capacity of the system you're building for a couple reasons. One, it's not that you want to overbuild all the time, but you can do the math and you can find out, what you need. Are you running an induction stove? Are you running an inverter? What type of inverter are you running? Are you running, a 1,000-watt inverter, 2,000, 3,000, 4,000? The kind of rule of thumb, or this is my rule of thumb, is if you have a 1,000-watt inverter, you probably have one battery. If you have a 2,000-watt inverter, you probably have 200 amp hours worth, or two 100 amp hour batteries. And then if you have 4,000, you can safely run a 3,000-watt inverter. Why is that important? Because it is the amount of current, the on-demand current that you need to pull across the battery bank. Because, Daniel, Will it's awesome. I've watched, I don't know how, probably 100 videos. I got to him about 3 years ago, and they were he just has really good information. But as far as the capacity goes, you need to also find out. Now we'll talk about this over here. This compare and contrast. So I have the specification sheets pulled up for each battery, and I'm going to teach you how to read the spec sheets. So the next thing would be dimensions and weight. The dimensions, that's quite obvious. Where do you want to put the battery in your van? Do you have room? What's nice is 9 times out of 10, these batteries are going to be in the same form factor because they're kind of mimicking the car battery format. I forgot what that format, the name was, but they're kind of mimicking that format. So they're usually all about the same size. So for example, like if you went to the SOK, then this is your typical your battery format. Oh man, get those millimeters out of the way. And then the next thing is once you know what size, the capacity of the battery, the dimensions you need to place it where you want to place it in your van. Consider the weight, but all lithium iron phosphate batteries they're pretty much the same weight. I think they're like 34 pounds, 27 pounds, stuff like that. The next thing is features. Do you have a BMS like the Victron Energy system where it's a separate system that plugs into the specific batteries, or you have internal BMS? Does it have that low temperature disconnect? One thing that it's a cool feature, I don't think is important, but does it have Bluetooth connectability? Can you individually connect via Bluetooth to each of your batteries? That's kind of a cool feature, but I don't think it's necessary. If it's included in the price, that's cool. And then speaking of price, budget. So budget is the last item. And the reason I say that is it's more important to know the capacity first and size out your system, and then take a deep breath and then go look at how much the batteries cost. Because you can't get away with your capacity, because I'm telling you guys, write down everything that you're going to want to do when you go on that trip. You want to recharge your computers. How long are you going to stay out there? What are you going to run when you're out there? Induction stove, microwave. You're going to be cooking a lot. Is it going to be, in the wintertime where there's not that much light outside and your solar is not going to kind of get you that optimum power during the day? All kinds of stuff like that. Or do you want to forgo solar and just do it off the engine and have a bigger battery bank so that you're not always worrying about how much power you have? So kind of overdo it. So let's get into the next part, the actual batteries themselves. So we kind of know the nomenclature about what we're all sizing here. And the next thing we're going to do is we're going to talk about the life cycle, warranty, and cost. And let's see here. Let's edit that. We'll put a little comma. There you go. So life cycle, warranty, cost. And so check out these 3 examples. They're pretty much spot on the same. There's a couple different differences as far as specifications, but they're really, really close. So SOK, this battery is, so this guy, let's see here. So this guy's made overseas. It comes in a metal housing, and I like it because the price, but the specs are really, really good. So let's start going through these specs. How do I want to set this up for you guys? Let's go over this, and then we'll dive into the specs. So SOK has a 4,000 to 8,000 cycle like a charge cycle. That's charge and discharge. So that's how many you can expect to get out of it. And it also, depends on how you use the battery. If you fully discharge it or you halfway discharge it, that sort of thing. They give you a 7-year manufacturer's warranty for, workmanship, build quality, that type of thing. Pretty standard. And it's $570 for this one battery that's 100 amp hours. So next up, we have Battleborn. Battleborn, everyone knows Battleborn. They're kind of, the go-to if you didn't know anything about batteries. They're a good battery. But check this out, 3,000 to 5,000 cycles. So that's interesting that they advertise that. They have a 10-year warranty, though. So that's nice, a little bit more than SOK. But if you look at this, we're like $300 more. Pretty close to the same specs. Again, we'll go over specs in just a second. And then we have Victron Energy. I could not find the cycles in any of their data sheets, so they don't have like a cycle count. Maybe if you guys know that, you can let me know, but I couldn't find it anywhere. And this 5 years, it was hard to find that too. When I found it, it said 5 years with the option to purchase an additional 5 years to make it a 10-year warranty. So after you spend $1,026 on the battery, you're allowed to buy more warranty. Oh, so nice. But I really can't hate Battleborn and Victron. Great batteries. SOK, you can't beat the cost on this. We've been using these batteries. Let's see how many months. March, April, May, June, July, August, September, October, November, December. Probably 10 months. Cycling on and off. And there's only one time that they got so dead that they actually had to disconnect. And that had to do with, no sun, weather. Thomas wasn't driving enough to fully recharge. And at the same time, the fridge was running 100% full out. But that's a cool thing. It's cool that the whole system is robust to where it all works. Everything kind of self-healed. Sun came back. He drove it for a couple trips. Everything came back on within, fully charged within 2 or 3 days. So it worked. It got down to its low state and did all its things that it said it would do. Okay. So that's what we're doing. So next we're going to get into comparing and contrasting, and then I'm going to teach you how to read these spec sheets so you kind of understand what they're talking about. I'm going to pause on this. I'm going to pause really quick. Let's see here. And just catch up on these on the chat. Say Daniel, single burner induction stove, EcoFlow, 75 liter dual fridge, freezer combo, and all the YouTube I got. Good. There you go. Yeah, if it's all running that, it's good. Let's see. Renogy good? Yeah, Renogy's good. So everything in my personal van is Renogy. The battery's not Renogy. The battery, I'm trying to think. It's been a couple of years. What battery am I using? I don't know off the top of my head. I have to go check it out. I will go check it really quick. But I just have a single 100 amp hour battery. Let's see. Let me go check real quick. We got YouTube. Yeah, keep the questions coming. I'm going to go up here. I need to search for something while you guys are thinking of questions. We will get to the spec sheet here in just a second. Let's see here. Yeah, I'm looking up. I got this video that shows the company that I used for my van. Let's see, here it is, right here. Ames Power. Yep, Ames Power. So I have a 100 amp hour. So this one right here, when it comes up. So this is what I have. It's an Ames Power, 100 amp hour. This is back in the day when I was first building my van, so definitely on a budget with that van, and I got this off Facebook Marketplace. The person I bought it from didn't know how to charge the battery. They kept trying to use a lead acid AGM battery charger, and they said, "Man, yeah, there's something that's just wrong with the battery." And I was like, "Yeah, I think I can figure it out." So I got a really good deal on that. But Renogy, so Renogy is what this van is going to have. So I already have 3 of their batteries. I'll show you one. I have it right here. So this is a Renogy 100 amp hour. This battery in particular is the fancy one. So this has a built-in heating function. So this will allow this to charge in extremely cold temperatures. So it's got built-in heater in here. This is smart lithium. This one is not the Bluetooth version, and actually, is it? Let's see here. No, at the time I bought this was a way better deal than the Bluetooth, but now I think they by default have the Bluetooth in there. Anyway, these batteries are cool because they're a smart battery, and they have an uplink in the top, and they come with a little power switch, and you can turn these into sleep mode or shelf storage mode. So they go to like an ultra low power state inside. So there's features like that. So I've got 3 of these, and I'm going to actually buy 3 more. I'll tell you why in a second. So the plan is to put a Dometic RTX 2000 AC unit in that van, and you need a minimum of about 600 amp hours to get a good night or 2 of AC usage. And what I mean by that is a night of AC and then enough battery left over to run the components in your van while you charge up and drive. So yeah, short answer, Renogy batteries are good. All the solar panels I use are Renogy. I even use the DC to DC charger. And see, while we're talking about it, let me just pull this. So Renogy came out with this product about a year or so ago, and it's the 50 amp DC to DC onboard battery charger with MPPT. And what's really cool about this is it charges via alternator. It has integrated MPPT, so it's a DC to DC charger. It's an MPPT solar charge controller, and it has a function to where if it senses that your engine battery is too low of a voltage, it will reverse safely and top off your engine battery of your car. It does a lot of stuff. So this is a pretty cool unit. I'll show you what it looks like, and then I'll get back to the stream here. This is what the unit looks like. So it's big. I mean, this is my hand. So this thing is big, but it has if you look at the back, it gets pretty warm. Look at that. Look at those heat fins. So you definitely need to make sure you offset it from wherever you're charging. But what's cool is these caps come off, and then you just put the wires through here. So it's a nice clean setup, and it's kind of a one and done system. So yeah, since we're talking about Renogy, let's see what else we have here. Yeah, people use Renogy for off-grid cabins. I think Renogy is just a. I have to call it a budget brand because that's where their pricing's at. But they're a really good budget brand. I've had a couple things that I was using on my personal van, like the PWM solar charge controller. You know, I called up their customer service to get some help on something, and I mean, they're really on top of it. I mean, it took them a while because, you know, it was during the last 2 years with everything going on, and but they, you know, they got help tickets. They're really organized with kind of getting back to you and doing a follow up with whatever problem, like return, question like that. Yeah, but for off grid cabins, I like Renogy. They have here. So before we get into batteries, we'll get back to battery specs. I think this is good just to talk about this during the stream. But if we go to Renogy, so this is what I like about Renogy. When you're a builder, you want to have quick answers, or just say you're an engineer too. You know, I want to look at the specs of things quickly. So if I just click on the solar panel, I know I can scroll down really quick down here to the bottom, and I can look at the specifications. They're right here. And then if I need more information, I can click here, and their spec sheets are just great. I mean, look at this. All this information, the size of the solar panel. It's just very helpful for me when I'm, you know, putting a build together, because I can do all the math first before my customer purchases the items. I'm not using my customer as the kind of guinea pig to figure out if something's going to work or not. I can do the math first, you know, put it on paper, build it, and then keep going. Let's see here. The Blue Eddy. Yep, those are good. Let's see, what was this? So Goal Zero was also good. If you guys are, if anybody is looking for other types of power systems, so we'll probably talk about this a little bit more at the end of the stream. I want to get through the spec sheets and teaching you guys that, and then keep the questions going, because I think the end of this stream we'll talk about different options, like Daniel was talking about, different battery options that you can choose from. These are lithium, but because Daniel, I think you were talking about like lead acid AGM sizing. All right, so let's talk about, let's see. Let's see here. So let's talk about the spec sheets. And I'm going to show you why these batteries are pretty much in line with each other. So if we go to the SOK, and I'm just going to pull out specific things. I'm only going to show you guys the important stuff that stands out to me, and it makes a difference between these two. So the nominal voltage, that's important too, because that is has to do with kind of like the voltage that your batteries are typically going to be at. Because when you charge a lithium iron phosphate battery, it's going to get pretty high, 14.6, and then it doesn't stay there forever. It kind of starts drifting down. But really, the most important is 100 amp hour. So your capacity, 100 amp hour. Then you want to move down. This stuff right here, it's not that important. The next most important thing is your maximum charge current. So there's going to be a recommended. The reason I bring up maximum charge current, how long do you want to drive to recharge the batteries? And then how long do you want the sun to recharge your batteries? I mean, you're going to want to push it to, so like that Renogy device that I had, that's why they make a 50 amp version. The other reason that 50 amp is usually a max, is because your engine alternator can usually safely provide that much amperage to another source of charging without burning up. And then also specifically for the smart alternators. So gosh, I can't talk tonight. A smart alternator is a newer alternator in cars, trucks, and it's important that when you get a DC to DC charger, that's the charger coming from your engine's battery to connect to like your lithium battery to charge it. It's important that it's smart alternator approved. So what that means is, instead of it can sense the voltage that. So when you have a smart alternator, when you crank your engine up, it's usually at a lower voltage, so it's not charging your battery system. And then when it discovers a load, it'll kick up. So I could be wrong in this, but the DC to DC chargers that are for smart alternators create that circumstance in which the smart alternator will wake up and increase the the current output to begin charging. That was a long-winded way to explain that. So maximum charge current. Wait, let's go back. Maximum charge current, that's what you want to look for. The recommended charge voltage, when you buy a DC to DC charger, and let me know if you guys don't know what a DC to DC charger is. It's completely fine. But when you buy a DC to DC charger, you're going to have a couple options on there. It's going to say, is this a lead acid, an AGM, or a lithium iron phosphate chemistry? It's going to ask you for the battery chemistry. Based on the battery chemistry, there's set values for charge cycles. And so the example of the Facebook Marketplace guy where I bought the battery from, he couldn't get the battery that's in my van. The reason he sold it to me is he couldn't get it to charge, just because he didn't have enough juice going to the battery to charge it. So the battery was always dying because it never got topped off. It never got fully charged. There wasn't enough voltage to charge it. So that is what the recommended charge voltage info is about. This one is very important. Maximum batteries in series. So that's how many batteries you can connect at one time. So that might be a deal breaker for you. For example, if I need to do 6 batteries like I do in this van, which Renogy can do, this one recommends only doing 4. So that's why we have 400 amp hours in Thomas's van. Now, SOK, check it out. They have different products. So in that case, maybe you go up to a 206 amp hour battery. So this guy, let's just see if this one can. Okay, so see how the maximum batteries in your series is 4. So since we go up to 200, that's how we can get more batteries. It's the same number here, but we've doubled our amp hours. All right, stay with me. Boom. Let's get rid of all this. Now, current is 100 amps. Peak discharge current is 200 amps. This is really important right here. So say that you are running an induction stove and you have 200 amp hours of batteries. That's your battery bank. Yeah, 2 100 amp hour batteries. And you have an inverter. You need to make sure that your peak discharge current is enough to support the inverter that you choose to buy. So if you have 2 100 amp hour batteries, it wouldn't be wise to have a 4,000 watt inverter because your peak discharge current may not provide enough current to the inverter, and it's not going to work, or it's not going to work properly. Your BMS discharge cutoff current. So this would be the protection for your amperage. Discharge cutoff current. Yeah, I guess it's an over current situation. That's when it cuts off. And then your low voltage disconnect. This is important too. So this will save your battery if you leave something on too long. So if you leave something on too long, that's the low voltage disconnect number. And then the BMS. Okay, so the recommended low voltage disconnect, what that means is at 11.2, if you have a system, so like a Victron system, or maybe you have a Renogy system where you can dial in where you want it to cut off, like if you have a way to dial in the cutoff voltage for the system, so this is not the BMS of the battery cutting itself off, this is the system disconnecting itself. If you can do that, this manufacturer recommends you do it at 11.2. But if you don't have that, the BMS is going to cut itself off at 10.4. So it'll let you drain the batteries out just a little bit longer. And then the reconnect voltage, when it is allowed to be charged back up to 11.6, the system will cut back on. Let's see. And then over here we just got dimensions. We got the weight, metal case. They do have a waterproof option. So if we go back to SOK and we go back to products, we have a marine grade. So this is a fully sealed battery. And it is, what is that? Hold on a second. Yeah, it's hilariously $1 more. I bet that's an inventory thing. But you got plastic sealed marine grade. So if you wanted to buy this for like a boat or something like that, or you did want to, you probably get this one. But the nice thing is this one, it used to not be able to be opened, but I see that they have these, I see that there's these screws, so you can't open it. So down here, battery is serviceable. That's probably the big bonus that everybody likes about SOK is you can actually open it up And if you needed to replace a damaged cell, you could do that. You could go online and buy a new cell. So you could rebuild your batteries. So let's go back to the specs. We have, the weight. They even give you the terminal torque. That's nice. All right, so here's the next important part. Oh, wait, I'm not even showing you the screen. There we go. So discharge temperatures, it'll discharge down to -4 and up to 140 degrees Fahrenheit. It'll charge in a range of 32 degrees to 113 degrees. This is storage. BMS high temp cutoff is at 149 degrees. The reconnect is at 131. But Will Prowse did test it, and this 32 right here, that is the low temperature disconnect. So that's why it does not operate below that. Here's some dimensions. All right. So next up, we're going to have Battleborn. Battleborn is also Dragonfly energy. So if you see those around. And let's come on down here and let's start picking away at this. So this one is 31 pounds. So the SOK was 28 pounds. So, pretty similar. This one actually goes down to -4 degrees Fahrenheit. So a little bit below freezing for operating temperature. It's water resistant. But they shouldn't be submerged. It's got a built-in BMS. So here we got 14.2 to 14.6. The SOK, 14.6. I mean, these are pretty much all going to be the same. So charge rate is 50% of the battery bank capacity. So 50% of the battery would be 50 amps. Charge temperature above freezing. Discharge can go a little bit below that. That's quite a bit. But these higher numbers are about the same just for the chemistry. And then this right here is explaining how you can take the 12 volt 200 amp hour bank. So this is the same example I was giving you guys. How you can continuously run 200 amps for 30 seconds, or a situation where you could do 400 amps for 30 seconds. So when we were talking about the peak discharge current, this 200 amps, typically it's going to be twice the amount of the amp hours for a short burst. So say you're turning on your inverter, there's going to be a surge of current to kind of kick on that inverter. So the surge should not last longer than, a couple of seconds. So they give you 3. And then if you need to pull a full 200 amps, this one says 3 seconds. Sometimes it can be more. So for example, this one, it can do a little bit better. It can do a surge for 30 seconds. So twice the amp hours for 30 seconds. So if that makes sense. Moving on down. So this is the BMS, and it's pretty much the same things that SOK is going to have. So right here we've got overcharging, short circuit, low temperature disconnect, and then the options here: high voltage, low voltage, high temperature, low temperature, balancing of cells. So they're all going to be pretty much the same right there. And then they actually give you a little chart on how to size the cables properly. So these are the cables that are connecting each battery to themselves. And so if you have a 100 amp hour battery connected to a 100 amp hour battery, you have the potential of 200 amp hours to be, or 200 amps to be pulled through that battery. So if you look at this chart, you've got, 150 to 200 amps being pulled through. You're looking at a 2/0 gauge wire. And so that's what we used on Thomas's van. You can see the longer you go, the bigger the wire you need. Actually, I think we use 4/0. I'll have to check my notes. And then at the bottom here, they just have some stuff on how to maintain your battery, the return policy, and then here we go. We've got our, so this is their kind of warranty, 10 years, this many cycles. Daniel, this might show you what, maybe you were asking this question about the difference between lithium and the lead acid options. Essentially, lead acid, it can provide pretty much the same, power, but the depth of discharge is why people like lithium so much. You can use more of the battery, whereas a lead acid, you can't discharge it past 50% or it'll damage the battery, the life of the battery significantly. Plus the cycle count is much lower, and besides the depth of discharge, most people like that, it's almost a quarter of the weight. Warranty's longer. Not existent. That's funny. So this is actually a pretty good chart for anybody that doesn't know the difference between a lithium iron phosphate and a lead acid chemistry as far as battery life, warranty, stuff like that. Then they give you some stuff about accessories. That's pretty much it. All right, and then finally we have Victron. So this is our most expensive battery. So Victron, their stuff is a little bit more challenging to read and understand. It does have integrated BMS. I had to go with the lithium super packs as the example for you guys tonight because most of their batteries they don't include a BMS in them, and they're relying on you to have an external BMS, which is, if you look at the really big builds like the 24 volt systems and 48 volt systems that some people have, just a little bit more technical with their stuff. But if we go to the 100 amp hour right here, you can see that you got 100 amp hour. They have 2,500 cycles, which seems really low. So the max continuous discharge. So this is where you got to be careful. One of their batteries has only 50 amps of discharge. So that's not good. If you have 200 amp hours of a battery bank and you're trying to power a 2,000 watt inverter, which should be fine. So actually, if you go on Renergy's site, let me just see if I can pull this up. I hope they have this chart on here still. Let's see. So if you go on Renergy's site, if you look up the minimum 12 volt battery bank sizing, I like this chart. It's very simple, straightforward. So if you have a 700 watt inverter, you need at least 150 amp hour battery or at least 100 amp hour battery. or their 170 model. If you have a 1,000 watt inverter, you need at least two 50, one 100. If you have a 2,000 watt inverter, look at this. You need, let's just stick on 100 amp hours. You need two, because you need 200 amps potential to serve the 2,000 watts of current. And then if you have a 3,000 watt inverter, you need at least three 100 amp hour batteries. So check this out. The Victron, if you don't buy the high current model, so say you accidentally bought this one, if you don't buy the high current model, you're limited to only 50 amps. So if you buy two of these, you're only going to get 100 amp hours discharged. So it's like you're powering a 1,000 watt inverter when you're really trying to do a 2,000. So those are the little nitpicky things that you got to watch out for, is this right here. Now you can, it'll let you do it for 10 seconds, but that defeats the whole purpose. These are the same. Max continuous charge current. So look at this. You got 50 amps for this one, and then you got 100 amps for this high current. So that would be a bonus of the high current model, is that you could have two 50 amp chargers charging that quicker. But guess what? You're going to pay for it. Actually, that one that I just showed you, this, again, no affiliation with Van Life Outfitters. I'm just using their website to show the product. This is not the high current version. Let's see how much the high current version is. So I don't even see the high current here. Let's see if I can find it real quick. Yeah, this stuff. Oh, here we go. High current. What is this? Nope, still 50. All right, we'll come back. So pay attention to that. Come down. Parallel, yes. Unlimited. So that'd be going to like, let's see, discharge down to, okay, storage. So pretty close. And then, so that's pretty much it. So their data sheet is pretty simple. So there is a benefit because you can charge the high current version very aggressively at 100 amps. I don't know why this is so low, because on their warranty sheet, I found this number. Oh, wait, never mind. Maybe that's our answer. 2,500. So, yep. So let's look at these prices one more time, and then I'm going to come back, check out the comments, and then that might be our stream tonight. So if you got a question, hop in here and put your question in. So final thoughts. The SOK, it's got a good warranty. It's got good charging cycles. Pretty much in line with the Battleborn and Victron Energy. If I were to buy 4 of the SOKs, it's going to cost me $2,280. So this is the example I'm giving you for Thomas's van. The SOK, $2,280 for those 4 batteries. If we had bought Battleborn, it's $3,496. And then if we bought the Victron batteries, that's $4,104. So almost double. So we could if you went with an SOK system, you could double your system. So it was a pretty wild. Yeah, so let's check out the chat here. So it looks like we don't have any questions. Yeah, guys, I hope you enjoyed this live stream. This is that sheet. You guys can pause the video, maybe take a screenshot of it if you wanted to have some notes from that. So Red Arc does not have, I don't think they have batteries. So Red Arc is a power system. They're like a power control system. Actually, no, take that back. They have. It looks like they have I don't know about the Red Arc batteries. So they actually have lithium deep cycle batteries here. That's pretty interesting. And see, they have that chart. So they show you. Oh, this is actually pretty cool. So they've got a chart. If you don't know about Red Arc is an Australian company. They make kind of overlanding power system setups. That's what we use for Thomas's van because we wanted to have the wireless Bluetooth connection to his system so he could run all the circuits off of his phone. So that's a perk of Red Arc. And it looks like they got a really nice chart here to show you, are you doing an air compressor, laptop, 2-slice toaster? That's such a random category. Coffee machine. That's definitely an Australian thing. Hair dryer, straightener, microwave, electric kettle. And then it shows you the different inverters and then how many batteries you would need to power that. And this all looks pretty adequate. So you see 1 battery for 1,500 watts, 2 batteries for 2,000 watt inverter. Good thing to point out. Then they got like a little video here. Their management system. So they do have batteries. Interesting. So let's see here. There's deep cycle. So here's the lithium. I'm not sure why they're combining deep cycle with lithium. That's interesting. So that is, wow, man, that's really expensive. They're selling that battery for 2,000. No. So that battery's even more than Victron. Man, that is so much for a 100 amp hour battery. Let's look at the specifications while we've learned what to look for. Okay, that's normal. That's normal. This is not normal. So this is a Pro right here. The maximum discharge is 170. Well, no, that's 30 amps less than the Battleborn. The peak discharge. Okay, maybe. So if this is true, I don't know how that's possible. I'm not sure how 400 amps is possible out of the 100 amp hour. See, yeah, these two things to me don't make sense. This doesn't make sense. Because if you can do this and this should be like 100. This should be like the Victron Energy. 3-year warranty. Yeah, I love Red Arc, but I do think that they kind of maybe white label, rebrand some stuff like that. I'm not sure if I should say that on the stream, but I just want to be honest with you guys that that's there's probably a bunch of brands that are using this because that is expensive. they make really, really good stuff. So it might be possible that this can do something that at the current moment I don't know that it can do. Anyway, Daniel, 24 volt and 48 volt. Yeah, let's talk about that. So there is a there's a math equation that I'm going to show you a picture, and it's going to explain the relationship between voltage, current, voltage, current, and amperage. Hold on, let me just pull it up. Ohm's law. That's what I'm talking about. Oh, what were you talking about? 24 and 40 volts. So ask me that question one more time. I'm going to show you. So if you guys remember back in school, there's something called Ohm's law. And it's what you use to calculate the relationship between voltage, current, and resistance. And you have this little triangle. So what's interesting is another way that you can look at the relationships between, I wish I had a better picture. I don't know why they're doing IER. Let me find another picture here. Oh, the exchange rate? Oh, yeah. Well, maybe it didn't calculate the... I'm not sure if that... if that's a good deal, they make... Red Arc makes really good components. So I can imagine if they're selling a battery, regardless if it's rebranded for their systems, it's probably legit. All right. So we're going to get a little nerdy here just for a second, because this is going to show you, I'm trying to find a good example. So essentially you have this relationships between watts, amps, and volts. And if you think of your household power, so I used to DJ, and when I set up my sound system, I knew from my experience with, Ohm's law and all this stuff in a different sense, I applied it to DJing. Anyway, long story short, if you don't have enough power to power your speakers, the Ohm's law is always in effect. You can't change this law. So if you have a power system like your batteries, if anything in the triangle gets messed up, it has to go somewhere, because you can't what is that? You can't create or destroy energy. It just moves into one different form. So, for example, if you have like a 100 amp hour battery and it's at 12 volts, then you're going to have a certain value for your wattage. And so you can multiply. I'm not sure how long I want to go down this rabbit hole. I'm trying to prove a point here in just a second. So if you have like 100 amp hours and you times it at 12 volts, you're going to have 1,200 watts. So let me use my pad over here. I got to pull up my... All right, let me pull up this notepad really quick. Come on, load up. This is important. This will make you be able to understand the relationship between the batteries, your inverter, and the stuff that you're using. Oh, let's see, 24 and 48. I thought it was the Australian battery, but there's a company down south in USA that makes the lithium battery system. Okay. Interesting. Trying to figure why my notes are not opening up. There we go. Here we go. Okay, to the drawing board. So hopefully you guys can still hear me. Okay, so we're going to do, we've got our triangle where we got watts, amps, and we got volts. So if we have a 100 amp hour battery so at the current moment, think 100 amp hours is 100 amps. That is what it is, but the amp hours are something on its own as well. But we're just going to stick to 100 amp of current that the battery can provide times 12 volts. This will change. It could be 14.6 at a maximum. You could have a lower voltage all the way down to like 11.6. So this range is going to change this number. But just for the example purposes, we're just going to stick with 12 volts. So you have amps times voltage is going to give you, so you got 1200. This is going to give you your watts. So the reason you need, so say you have 200 amps times 12. Man, we got 2,400. This is why you need two 100 amp hour batteries. This is why you need two 100 amp hours. So we need two 100 amp hour batteries to run a 2,000 watt inverter. So that's why they make that designation. And that's why you need at least one 100 amp hour battery to provide the 1,000 watts for a 1,000 watt inverter. Okay, does that make sense? Now, this is how you troubleshoot problems. So, take this example right here. And since it's math, if anything changes within it, it affects everything else. So, for example, if your current, say your what's the best way to do this? So we've got, so like say that we had our voltage dropped, then our current would increase, if that makes sense. Yeah. So we're going to go down we've already been streaming for quite a bit. We're going to go down a wormhole if I start teaching you that. I think that would be perfect for another video because that would be good in a van safety video, because if you're having wires in your van that are heating up, you don't know why, it's probably because there's some type of resistance that you're not accounting for. That can be a power draw that's too much on the system that you didn't calculate for in the beginning. That could be a system that's trying to charge your system and it's not doing it properly, and it's causing a lot of heat because either you didn't size the wires appropriately coming from the battery charger, like the DC-DC charger, to your lithium batteries. So you can use this formula right here when you go to lay out all the components of your van. If you didn't do it right there, it's going to show up down the road in your van build. Let's see here. I'm going to do about 1 or 2 more minutes. If you guys have any more questions, pop them in and we'll answer them. All right, so don't see any more questions coming through, so we're going to go ahead and end the live stream tonight. Thank you guys so much for watching. Thank you for the questions and comments. And yeah, this definitely helps us for more content in the future. So we'll break this out into some other things based on these, as well as this thing that we talked about, because I think this will really help you when you're laying out or troubleshooting the van later on to, you know, find out why wires are hot and that sort of thing, kind of what I just talked about. But yeah, thank you guys so much for watching, and we'll see you in the next live stream.